Hello all and welcome back to another lesson of pre-calculus. We are heading into section 3.3 where we will be looking at logarithms and how to eventually solve logarithms. So right now we have to learn all the properties of logarithms. So if we are in our notes packet, we are on page 1 of the 3.3 to 3.4 notes packet. And you can download that on the Canvas website. And we're looking at page 1, and we are just going to be discussing logarithms and how we can manipulate them using their properties. Now, a logarithm is just an exponential. So therefore, it's going to mimic the properties of exponentials. Let me go ahead and make my pen a little smaller. It's a little too thick. There we go. Okay, so if we forget the properties of exponentials, let's quickly go over them. Remember, we have one property that says if I have a number raised to a power multiplied by another number raised to the power, then I can go ahead and add those two exponents together. If I have a number raised to the power and I have another number raised to the power and I'm dividing those two things, I can go ahead and I can subtract the exponents. And if I have a number raised to a power all raised to another power, I can go ahead and I can multiply my exponents. And those are three of my exponential rules. So the rules we're going to look at today for logarithms are going to mimic these exponential rules. So when I'm talking about these logarithmic properties, I'm using the letters A, M, and N. Okay, M and N are both positive numbers. A is going to be the base of my logarithm, and then P is going to be any number, any real number. So here it says the product property, where it's log base A of M times N. Okay, this property is going to mimic this property right here, which is the product property for exponentials. So because when I'm multiplying two exponentials together, I can add their exponents. Very similar idea here. If I'm multiplying two things inside of my log, I can take those two things and add them together. So this can be expanded to log base A of M plus log base A of N. For example, I have log base 3 of 9 times 27. This can be rewritten as log base 3 of 9 plus log base 3 of 27. If I wanted to condense logarithms, so if I can reverse it, because I have the same base, here I have log base 2 of p cubed and log base 2 of q, as long as the bases are the same, I can condense them into one log to make it log base 2 of p cubed times q. And that's all inside of my log. I like to use parentheses when I'm talking about inside of the log just because some students get confused with what's inside and what's not. So I like to use parentheses. We also had a power property. If I have a log base A of m raised to the power p, I'm allowed to take this p and bring it in front and multiply it. So this would become p times log base A of m. Okay, for example, I have log base A of 11 to the negative third. I can bring it negative 3 in front and call it negative 3 times log base A of 11. For this one, I need to rewrite this log because I don't see an exponent here. But I have the fourth root of 7. The fourth root of 7 is the same thing as log base A of 7 raised to the 1/4. right? Taking the fourth root is the same as raising it to the 1/4. And now I can go ahead and use my power property, and I end up with 1/4 times log base A of 7. And then there's this guy, which I'll just slide right over here. I get natural logs. They have the same rules as regular logs because natural log just means log base E, right? ln is natural log. So this has become 6 times the natural log of x. And then the last property I have is the quotient property that says if I am dividing inside of my log, I'm allowed to break them up into 2 logs and subtract them. So I have log base A of m minus log base A of n. For example, I can rewrite this log right here, log base t of 8 over w, as log base t of 8 minus log base t of w. Or I can condense logs. So I have log base b of 64 minus log base b of 4. I can rewrite this into one log because they had the same base, and I can rewrite it as log base b of 64 over 16. Now, if I really wanted to keep going, I can do 64 over 16, which becomes log base b of 4, because 64 over 16 is just 4. Okay, so I can use these properties to expand or condense, depending on what the problem is asking for. Sometimes I have to expand, sometimes I have to condense. The actual problem itself will dictate what you're going to need to do. Now, on pages 2 and 3, there are a lot of examples. I'm not going to do them all, but I will do many of them. Okay, so here I am, I'm on page 2. We'll do a couple of examples together. I have log base 3 of 6 times 2. I can expand this using my product rule. That's log base 3 of 6 plus log base 3 of 2. Now I can expand this even more because 6 can be broken up into 2 times 3. So I'd have log base 3 of 2 times 3 plus log base 3 of 2. And now I can expand this part right here, which becomes log base 3 of 2 plus log base 3 of 3 plus log base 3 of 2. And I can do it one more time because here I have a common I have common terms, so I can combine these two terms into 2 log base 3 of 2. And then we learned in our last section that log base 3 of 3, if the base and the number is the same, it just becomes 1. And that would be my final answer. This and this are the exact same thing. Okay, I'm just going to erase this guy right here so I can have a little more room. We'll do number 2 together. Number 2 says log base 7 of 3 times x times y. So log base 7 of 3 times x times y becomes log base 7 of 3 plus log base 7 of x plus log base 7 of y. And now I cannot do anything from there. I just broke it up into 3 logs because they're all being multiplied together. Number 3 is log base 3 of 3 times x to the 4th. Now, the 3 is not being raised to the 4th power. So I cannot bring this 4 out in front because this 3 is not being raised to the 4th power. So the first thing I would want to do is I would like to split this up. So it's log base 3 of 3 plus log base 3 of x to the 4th. From there, log base 3 of 3 just becomes 1. And then this, we can use my power rule. I can bring the 4 in front. and it's log base 3 of x. And that would be my final answer. Okay. So that's expanding logarithms. Now we're on page 2 still, looking at number 4, and we're going to condense this log. Now you'll notice that there is no base next to the log. This is log of 9, log of 2, log of 3. Remember, if there's no base, we're implying that it's all base 10. That's the implication. Okay, so as long as they're all the same base, we can go ahead and combine these. First thing I see is I see this 3. This 3 in front of the log means I gotta put this back up here. So I'm gonna rewrite this as log of 9 plus log. Now 2 cubed is gonna become 8, right? 2 to the 3rd power minus log of 3. Now, these two logs are being added together, so it would be log of 9 times 8 minus log of 3. And now, because I'm subtracting 2 logs, I can divide and have log of 9 times 8 over 3. And of course, I can simplify. Once I have this, I can simplify the 9 into a 3, and the 3 into a 1, which just leaves me with log of 8 times 3 is 24. That's it, just 24. Log of 24. Okay, so I use my my power property first. You always want to get rid of these or put the exponents back up, and then I went ahead and condensed by using my product and quotient rule. Still on page 2, let's look at number 7. Again, first thing I want to do is take this 2 and put it back up here. So it becomes log of 8 squared is 64 minus log of 4 minus log of 16. Again, because they all have the same base, the base we're implying here is base 10, because there is no base written there, we're implying base 10. If they all have the same base, I can use my properties. I cannot use my properties if the bases are different. So we first have to check that the bases are the same. Since they are the same, I'm going to do 2 terms at a time. I'm just looking at these 2. Since I'm subtracting them, it is log of 64 over 4 minus log of 16. Now 64 over 4 becomes just 16, right? 64 divided by 4 is 16. So it becomes the log of 16 minus the log of 16. Now, when I'm subtracting these 2, we obviously get 0. Let me show you why. If I was to condense these, I would end up with the log of 16 divided by 16, which is just the log of 1. And remember, the log of 1 is always 0. Okay? So we're expanding and condensing. We're still on page 2, looking at number 9. This one looks crazy. Crazy. I have parentheses here. So let's work inside of the parentheses first. So log base 3 of 12 minus log base 3 of 3. So I have 2 times log base 3 of 12 over 3. Plus, and then I'm going to take this 1/3 and put it back up here. So it's log base 3 of 8 to the 1/3. Now 12 over 3 is 4. So I have 2 times log base 3 of 4 plus log base 3. Now 8 to the 1/3 is the same thing as the cubed root of 8. And the cubed root of 8 is just 2. Now I want to take this power and bring it back to the exponent. So it becomes log base 3 of 4 squared, which is 16, plus log base 3 of 2. And now I can combine these two logs to make it log base 3 of 32. So I first worked inside the parentheses. I could have, if I wanted to, I could have distributed this 2 to both of the logs. It would have given you the exact same answer. Okay, but I like to condense before I move this exponent back to the top. All right. Now on page 3, we're looking to expand. Again, I have this crazy radical. It's a cubed root. So the first thing I want to do is I want to take this radical and rewrite it. So it's log. Now there's no base, so we're going to assume it's base 10. So I have a squared times b over c to the 5th, all raised to the 1/3. Okay. Now I can take this 1/3 and bring it to the front. So it becomes 1/3 times log base 10 of a squared times b over c to the 5th. Now when we're expanding this 1/3 has to go with everything. So I'm going to put the 1/3 out in front. And I'm going to expand it. So because I'm multiplying a squared and b, I have log of a squared plus log of b. Right? Because I'm multiplying these together, that means I can add them. Because c to the 5th is in my denominator, I have to subtract log of c to the 5th. And the last thing I want to do is take all of the powers and bring them into the front. So I have 1/3 on the outside multiplied by 2 times log of a plus log of b minus 5 log of c. If you want to distribute the 1/3 to everything, you can, but I'm totally cool with you leaving it just like this. Okay, I don't want to have any exponents left over with my logs. I want to put them all on the front when I'm expanding. Okay, and here's another tricky one. This is also on page 3. This is number 3. I have log base b of a times y to the 5th over m cubed times n to the 4th. All right, let's break it up first. Let's just do log of b. We have ay to the 5th minus log base b of m cubed n to the 4th. Let's just do that. All right, I have a fraction, so I broke it up by using a subtraction sign. Now, I'm adding these two together, so I'm allowed to break it up into two logs, I'm multiplying these two together, so I'm allowed to break it up and add the two logs, so it'll be log base b of a plus log base b of y to the 5th, minus, now I'm multiplying these together, so I'm allowed to break it up into add two logs together. But when I do that, I gotta put it in parentheses. So it'll be log base b of m cubed plus log base b of n to the 4th. Because this negative would eventually have to be distributed to everything. So that's why the parentheses are huge. And then last but not least, I want to take all of my exponents and bring them into the front. So it would be log base b of a plus 5 log base b of y. Now I can also distribute the negative if I like. So negative log minus 3 log base b of m. And then I distribute the negative in here too. So minus 4 log base b of n. And this is my final answer of my fully expanded logarithm. Now I want to jump really quickly to page 6. There are problems that look like this, and I believe it's page 6. I guess I can double check that right this second. Give me one second. Let me just double check that It is page 6. Page 4, 5. Yeah, page 6. Okay. So on page 6, you will see problems that look like this. I want to walk through one problem with you. Okay, it says let log base a of 2 equal this number. Okay, and we're going to let log base a of 3 equal this number. And we're going to let log base a of 5 equal this number. So the red, black, and green. Okay, I want to find log base a of 6 over 5. So I want to utilize my properties to get this log into something in terms of these 3 logs. Okay, for example, I'm going to expand this because I'm dividing 6 over 5. I can break it up into log base a of 6 minus log base a of 5. Oh, what do you notice? Well, log base a of 5 is my green log. Right there. Log base a of 6, I don't see log base a of 6 up here. However, log base a of 6 is just 2 times 3. So if I rewrite 6 as 2 times 3, log base a of 2 times 3 minus log base a of 5. 2 times 3 is log base a of 2 plus log base a of 3 minus log base a of 5. And now what you'll notice is I have all of the logs that I have up top. I have my red log, I have my black log, and I have my green log. Now, even though we don't know what A is, we know what these values are, right? So this would be 0.3562 plus 0.5646 minus 0.8271. So even though we never figured out A, we did figure out that log base A of 6 over 5 is equal to 0.0936. So I was able to expand this to put it in terms of these values so that I can actually find the log base A of 6 over 5. So in this unit, we are just expanding and condensing logarithms by using the properties of logarithmic functions, and they mimic the properties of exponential functions. I'll see you next time.